Well, hi, and thanks for joining me in my shop here the last day of May. And I think now the next thing I want to do with this radio is test the vacuum tubes. So the impression I get with the way it's operating is it's not up to where it could be still. So a number of possibilities. Tubes obviously are one. Old capacitors are the other. So I think those are the two reasonable reasons why this radio may not be performing as well as it could be. So we're going to do the tube testing. I'm going to start at kind of the output end. Actually, I'm going to start with the rectifier tube, even though I doubt there's anything wrong with it, but we're going to take a check. 35W4, and we'll just work our way through the tubes one after another and find out what's up. So let me get the tube tester ready here for some action. Okay, so I think I've set this up now. Let's just double check everything. 35W4, 35 volts, good. No signal, it's a rectifier, no bias, it's a rectifier. 00763, 00763. 0100, 25 on the meter, E for the plate, everything's ready to go. Pop this in, turn it on. And of course, we already know in this radio that the tubes are generally working, so I wouldn't be surprised if they all test pretty good. We're going to find out. Check for shorts, just watching for the meter to jump up. Nope. Okay, and when we do rectifiers and diodes, this switch and rectifiers have to come up above where my finger is here. About halfway. Ready? Fire one. Way up there. That's only one test for this guy, that's it. Not hot yet. Great, that's one tube done. Okay, I think we're ready for the output tube. 35C5, that's correct. 35, that's correct too. There we go. Now let's check all these switches. Maybe I should check them before I plug it in, but I'm pretty sure I got it right. So filament 35, signal level 8, the bias is 18 high. Not surprising, this is an output tube. 15765, 15765, 4300, 4300. Good. 45 on the sensitivity. C for the plate, we're ready to go. Now, of course, this tube would be responsible for poor performance in terms of volume. If you can't get any volume out of the set, it could be this tube. Okay, and where is it supposed to come up to? 35C5 should come up to 940 on this test. 940 is here. Now, 940, by the way, when I say these numbers, that 940 is not the actual GM of the tube. If you want to get the actual GM, you would take the reading and in this case multiply by 4. That gives you the real GM. But 940 without multiplying is the idea. So 940 is just below 1000, right in this area. And it's good. It's a little above. Good. Okay, that's tube number 2. Turning out to be okay. Okay, ready on the next one, which is a 12AV6, when really the radio is calling for a 12AT6. Let's just do something. I've set this up for 12AV. Let's double check it. 12AV. So 13 on the filament. Correct. Signal 1. 19L 51760 0300. Very good. 35 and half. Great. Now that's for the 12 AV6. What if it was a 12 AT6? How different would the settings be here? So I'm going to reset them. I'm just going to call them out. 13.1 28L, so 28 different bias. Well, remember, this is setting the tube up so it can be tested in this machine. This isn't setting the tube up to show how it operates on a radio. That's not quite what's going on here. So the fact that the settings are a little bit different doesn't actually mean the tube itself is different. It doesn't mean that necessarily. That's my thinking. 51760 0300. So the pin arrangement is exactly the same. Sensitivity, meter sensitivity is the same. Plate's going to be in the same. Reject point's a touch lower, I think, here than the other one. So the main difference is this bias variation here in the test, which I'm not going to change it. Although it would be interesting, what happens if you test an A? Yeah, hey, here's an interesting thing we can try. We will test it as an AT6 in a minute. But first let's do it for what it really is. We're all set here? Are we set? Everybody's set? I think I'm set. In you go. That's a two-part tube. The first part we're testing is the triode that's in it. So we're going to measure the transconductance of the triode. Okay, let's see. Anybody leaky in there? No. Good. So up around 1,000. Just over 1,000. That's way up over 1,000. Now, so what is that number actually? The number is actually 1650, almost 1700. Let's remember 1700. 1700. Now I'm going to change the setting to the way the radio might be operating. Now, it's not really true what I just said, but you kind of think of it that way. 28L. So all we're doing is just changing this. We're doubling it, more or less. 28. Not even doubling it. Okay, now, so now, which, did I use this recheck point? 78. Let's just see what happened to it. Oh, it's much lower, so I can actually turn this while it's operating. So you can see the bias variation in the test here, quite dramatic. 28 would be here. Okay, so if I thought I had a 12 AT in there, I would look at this and go, that's 900. And its reject point is 780. So it's still testing in the good, even under the wrong settings. Maybe down the road what we'll do is I'll get a 12 AT6 out of my collection, test it, find it good, and then we'll put it in the radio and see what the difference is. If there's anything noticeable, flip back and forth. That sounds like fun, but for now, this tube's fine. Good. On to the next one. Ooh, got ready to do the next tube, then realized I only did half of this tube. This is a part two. The second part is diodes, 2 diodes. So I got this set up now for the diodes. Let's just go through it. No bias, bias not a concern. 01763, 01763, P000, P000, 48, A for the plate. Okay, P1 and P2. So P1 and P2 for 2 tests on the diodes. The diode's got to come up to about here. Not very high on the scale. Diode 1. And it's in the good. Diode 2. It's in the good. Okay, so I finally did test this entire tube. Okay, this next one, 12 BA6. Let's get that one set up. Okay, I think we're ready to go for 12 BA6. Yeah, it definitely says 12 BA6 on it. 13, 4, 10L, 52763, 52763, 4120, 4120, 33, whoops, 33 on the sensitivity. 33, C for the plate, almost 1,000 is the reject point on the meter. Now this 12BA6 is a RF amplifier, very common of course, and there's 2 of them in this radio. What's going on? There it goes. So this is the one that's in the middle of the IF string. It's between the two IF transformers. And some would say this is the most important tube in the whole radio, although each tube is important, obviously. This one's largely responsible for the gain of the radio, as I understand it. The front end 12BA6 in this radio, the RF amplifier, you might think that's there to boost the signal up, but not so much. It's there to just enable a, as I understand it, to enable a stage of amplification and tuning. So the main thing is that you've got a tune stage there. Anyway, I think we're ready to go here. Oh! Short showing in 1. Now, is that to be expected? I don't think so. Let's look here. So if there was a short in position number 1 expected, there would be a note in here. I think the note is F, actually. We'll have a, so it's definitely there, isn't it? No question about that. Now, it just could be the case. I happen to have another 12BA6 just laying around here. Let me take a quick look. No, I don't. Okay, well, I don't think we want to continue with this tube in the radio. Pin 1 in a 12BA6. Pin 1 in a 12. This is a fast access database I have. And it's a fault tolerant. Like if the power goes out on the house, you can still use the book if you can get near a window. It's fantastic. Here's a 12BA6. Pin number 1 is showing a short. So, ooh, 12BA6. So pin number 1 is the signal grid. Aye, he says. So in this tube tester, the reading here is an actual measurement. So this is actually an ohm meter right now, and it's telling me the resistance of the leak. And you can read it right here. It's right around 100K, 100,000 ohms. You know, if the meter moves just a little wee bit, at 30, 20 million ohms, it might not even care, but wow, this is quite a ways, down to 100,000 ohms. Would this cause problems in the radio? I would think so. Can I test this tube? Don't think I should. If this was all the way over to 0, I certainly wouldn't, but I don't think I should even try like this. Should this tube go back in the radio? Well, the radio tolerated it to this point. I need another 12BA6. Okay, so I'm going to hunt down the replacement. I have many 12BA6s. Okay, here we go. I mentioned before, I've been very fortunate at tube collecting. I really haven't gone out of my way. Somehow I've ended up with a pretty decent collection here. There it is. Not as many as I might like. 12BA6. Now all these tubes have been tested and have passed a sort of preliminary tube test. So let's try this one. Just making sure it's 12BA6. Yep. Oh, it's a little bit warm. Pop this guy right in here. Now, they passed the test in the sense that it has some kind of, like the heater heats and has some kind of conductivity through the tube. It's above the reject point. How much and all that, I don't know. We'll find out. Maybe while it's warming up, let me just double check my settings here. Why not? 12BA6, 10L, is it correct? 52763. 52763. I don't know how this would have changed, but then again, it's me in here. 33. C, yeah. Okay, now, what about that pin 1 short? Does it appear in this tube too? Not at all. Okay, giving this tube a test, and where is it supposed to come up? Just around 1,000? Oh, she's a lovely one. Okay, so this will go in the radio. This one, I'm going to mark this. I don't know am I going to do with it? Certainly don't want to put it in another radio. I mean, somehow we got away with it in this one. Yeah, wow, this one tube can make quite a difference in the operation of the radio. Well, so far I will have made only one change, and that's this tube. So far. Okay, let me not mix these up. The one in my right hand goes in the radio. And I won't even stop the video so I don't make a mistake here. Get the right one into the radio. Come on, go in the radio. Yeah, see, I should have stopped. There we go. Okay, the right one is in the radio. Great. Next tube. The next tube is the oh so important mixer tube. Okay, I'll get everything set up for that. Okay, we're about ready here for the next tube. 12BE6. It's actually a BE6A. I'm not sure what the difference is. There you go. I'll double check now. 13.4 on the signal level, 8L on the bias, 51763, 51763, 3000, 41. C. We're good. We're good to go. It says here in the notes, whole tube, heptode. So this is a single test for this tube. Here we go. Any shorts? No. She's good to go, and the expectation is 1570. So up in this area here, and it's just a little low. Oh, what was that? How come it jumped there? Sometimes it's my switch. Other times it's the socket. So it's reading 15 on here, and the reject point is 1570. Wow, that's really close. Let's just see how sensitive it is to the bias adjustment. Not terribly. The reason I do that is I'm thinking, well, if I got the bias slightly off, or if the calibration of the unit is off itself, and if the bias is really sensitive, maybe a slight misadjustment here causes a big change in the reading, make me reject a good tube, or the opposite. That's why I do that. So yeah, I think for now we can call this guy okay, but maybe not. Okay, okay. Yeah, okay, it's okay. I'm okay, you're okay, everything's okay. Okay, ready on another 12BA6. I should have tested this right after the first one, I sort of forgot. So I wouldn't have to reset it, but let's check it. 13, I'm sure I got this okay enough to put it in there. Here we go. 10L. Good. 52763. 52763. 4120. 4120. 33. C. Good. Okay, now this is the front end amplifier. This is the one that's going to, so there's a little bit going on here in setting number 2. But on the meter, that's over 5 megohms. Interesting question would be, what causes that kind of thing inside a vacuum tube? Just up a tiny bit on one pin. I don't think that's enough to worry about. 12BA6, we should be doing about 1,000 here. It's just a little on the low side, and well, it's actually below the reject point. So this tube is considered, bad back in the day when tubes were the business. This is how radio shops made their money, selling tubes. This tube, by the way, is made by Rogers. I don't know, can you read it on there? You can't read it on there, but it says Rogers. In Canada today, Oh no, back when this tube was made, Rogers was a radio manufacturer. Many of their radios I've had in my shop to repair back from the 40s and 50s. And I don't know if they ever made television sets. I suspect they probably did. And they made vacuum tubes. And they're a pretty aggressive and progressive technical company. They still exist today, but they certainly don't make tubes. Today, they are one of Canada's 3 or 4 large cable companies, TV, internet cable companies. So, for instance, my internet connection is from Rogers, so is my TV and all that. So Rogers, very large corporation here in Canada, and very successful. When Mr. Rogers literally decided to go into the cable business, he was all alone trying to convince people to hook wires up to their house, take down the antenna, and start paying them a rate. Now, doesn't that sound impossible? Hey, mister, you get free TV on that antenna? Here's a cable. You can pay me for the cable. Wow. That would be back in the early 60s. And look at it today. Can you find somebody on a TV antenna? No. Anyway, enough reminiscing back in the good old days. What should I do here? I think... Okay, so we know this one's not the greatest, but it seems to be working. So I'm going to put this back in the radio. Otherwise, I will have made too many changes to the radio to start realizing what change really caused the benefit, if there is going to be a benefit. Okay. In fact, let's just spin around to the radio here. We're going to give it a try. And then I think that'll be the end of the video for today, because my project for today is changing the front brake pads on my terrain. Okay, that's what I'll be doing most of, well, maybe not most of today. Hopefully not most of the day. Shouldn't take more than about an hour or an hour and a half to do. Okay, so tubes are in. We've changed one tube that had a short, which may have had absolutely no performance impact on the radio. Let's find out. It's plugged in. Everything's good. We're good. Everything's good. Power on. Full power on. Look at that tube. Woo! She's a bright one there. What's going on with this one tube? Wow. That's a little odd. So you can imagine it, like when the radio's, you don't have to imagine. When the radio's operating, the same current is flowing through every tube. It doesn't matter what the current is, it's going to be the same through every tube. They're all in series. And that's when they're all warmed up and they settle down to their proper resistance. But on startup, the filaments are cold and the resistance is different. And it could be the pattern of resistances is such that this guy takes a lot of power initially. And that's why it was glowing like a son of a gun. Okay, how's it working? Sounds better. Yeah, I watched the blast off. Great. Way to go, America. Way to go. So those are the 3 stations I like to test with at the low end of the band. 590, 640, and 680. 590 is the strongest. They were the ones that were talking about the space shot. 640 is a little less strong, and 680 is interfered with by a signal just above it, a noise signal here in my house anyway, just above it, as some radios cannot hear 680 without hearing the noise too. This is 680 right here. That's a news channel, so they're always giving news, traffic, stuff like that in Toronto. So the other station I like to check is the French station, which to me is the weaker of all these stations and separates the men from the boys. Let's go see if we can hear it. Could hear it last time, barely. So it's a huge change in performance of this radio by changing one tube. It's very dramatic to me. From what I remember listening to it yesterday, we could hardly hear these stations. Now they're actually listenable. Could be some of the, and could be if I change this tube, we might get even better. But I think I'm going to leave it there for today because I do have this other big project I have to do today. So what we'll do tomorrow, a quick check on the alignment to see if changing that tube has done anything. I can't imagine. It shouldn't have changed the alignment. Maybe I shouldn't even do that. Move on to trying to actually try to measure the amplification factor in the radio, although, you know, just by playing it, it seems to be kind of normal to me now. Maybe that's not worth trying. Another one would be check voltages through the radio. Look for bad bias. That's a good idea. But check voltages tomorrow, and then start plugging away on some capacitors. Maybe because these guys look great. There's also an experiment I have in mind, which is to remove the. I won't even tell you. We'll see, because you know what, I'll tell you what I'm going to do and then I won't do it because I won't remember what I said. That happens all the time on my videos, I think. So thanks a lot for watching this. A little bit of success here today, and enjoy your day.